All right, hang tight. All right, okay, there's the YouTube feed. Hey, everybody, sorry for that. What did I do? I ate some dark chocolate, I think, and it racked my throat or something. I don't know what happened. But hey, everybody, welcome. So we've got Dr. Seth Nielson in the house. I believe I told you Seth was coming. I believe I'm going to update the actual schedule on Canvas in the future. In the near future, like this weekend, I swear it. Do we have any housekeeping? I don't think so, right? We got anything anybody needs? Because we're just going to turn it over to Seth and talk security. And Seth, on Tuesday, we talked about Cuckoo's Egg. Went kind of deep and talked quite a bit about all that. I know you're a fan of the book. But yeah, Cole, yeah, I know, Cole. Yeah, still on me, but by the weekend, okay? By the end of Sunday, this is my promise to you. Hubert is now going to take my deposition. I swear, by the end of the weekend, okay? All right, that's all I got. Seth, it's all you, man.
Hello, everybody. I'm Seth Nielson. Normally, nobody calls me Dr. Nielson unless they wish me ill in like a deposition, you know, an attorney sitting across from me. Now, Dr. Nielson, you believe that? See, so usually Dr. Nielson is like a, you know, that's like a bad thing.
Like a
so,
pejorative?
you know, normally, yeah, it's a pejorative. So Seth suits me just fine. If anybody is asking a question and wants to be like, what should I call him? Seth is just fine. I'm here today to talk security. I love teaching. I love talking. So this is all kinds of good for me. And
in the update memory.
Do we got a hot
what I
mic?
did is I
think we got a hot mic, maybe.
Hearing people chatting, which is also fine.
Okay, do we got the hot mic taken care of?
Okay.
All right, mute me.
So, in all seriousness, though, I actually hope people feel like asking questions. In fact, I actually sometimes like to start out meetings like this by just being like, you all showed up to hear about security, and some of you have probably been thinking about it or wonder about it or have questions. Let's just open it up. Anybody have things they've just been desperate to just ask an expert in security? And let's start with that before I go into what I want to show you.
And Seth, actually, let me squeeze ahead of that because I really did a disservice here because I didn't really even introduce you, and I didn't really talk about you much before this. But just kind of for everybody's FYI, Seth, what's Seth? Seth is a PhD in computer science from Rice University, undergraduate and master's degrees in computer science from BYU. Seth was one of my graduate students who abandoned me and left to go get his PhD elsewhere. And then he's worked just heavily in the security area. His dissertation and research was all in that space. Seth actually had like 5 minutes of fame when he discovered a bug in the Google desktop. And it actually made the news when you were a PhD student at Rice when that happened, right?
Yeah.
And so Seth also has spent a lot of his career doing things in kind of the expert witness space, testifying expert, legal cases, intellectual property. And so we've kind of weirdly sort of come back and aligned. He also is adjunct professor in the computer science department at the University of Texas at Austin. Yeah, I don't know. Is that's not too bad. That's not too bad.
That's not too bad. I was going to throw out a shameless plug for I have written a book on cryptography. So if you ever want to do some cryptography with Python, there you go. Then,
I haven't read it. I'm sorry.
Hey,
but
it currently has 5 stars on Amazon, so I'm pretty excited about that. What else would I say about myself? I have done some interesting projects with ransomware. I've done research. I actually did I got a grant from the Department of Defense to do some research on ransomware. I'm really into, these days, I'm kind of also into like privacy and data security. I've been doing there's a large company. All of you know it. This large company had a data breach a while ago. Like, I wasn't involved in helping them clean up their data breach. That's not actually my area of expertise, right? Like, I don't do incident response, sometimes called IR, some of that kind of stuff. But they brought me in now where they're actually trying to figure out what could an attacker actually do with this data, right? Like, we know how to use the data because we have all the applications that use the data. But if you didn't have all the applications that we have and all the know-how and all the brain share, and you just had the data, what could you figure out from it? And they actually expected me to kind of come back and say, not much. That's kind of what they were hoping for. And let's just say they're having to make additional disclosures. So I found other stuff that was missing that they didn't know. But I've also been able to show them how attackers piece these kind of things together. That kind of, Sherlock Holmes kind of thing is a big thing for me. It all stems back to debugging student code. When I was a TA as an undergrad, I was always, how do I reverse engineer what happened here? I think that's where I get it from. So just kind of some interesting experiences. Well, if I was referring to SolarWinds and Microsoft, I couldn't tell you if that's what I was referring to. But I'll tell you I wasn't. But don't keep asking, because from here on out, everything else I'll say is no. No comment. Although the SolarWinds Microsoft hack is actually really fascinating. We should probably touch on that at least a little bit before class period's over. So I'm trying to think if there's any other really exciting projects I've done. Oh, I'll tell you one that you think is interesting. I was on a team, I actually was leading the team where we were hired by a medical device manufacturer to try and figure out how you could attack their infusion pumps. Infusion pumps are the things that pump drugs into you at a certain rate over time. And yes, we found out they could in fact be hacked very badly, remotely, en masse. So that was kind of an interesting project. The company was actually a really cool company, and there are reasons why it's hard for medical device security to kind of catch up. And they were very open, and they didn't just ask us to show them what was wrong. They had us like do some training on how to change their processes to know how to make their things more secure in the future. They'd never really had to deal with security before because medical devices have typically not been connected to the internet. And so they were going through some growing pains as that was happening. So those are some interesting projects that I've done. I've taught some interesting things in my classes. I like to try and teach in experimental ways. I did once for an advanced class where I set up a little very, very basic game board. Don't get too excited about game. It was the most, you were just moving little bots around on a text board, but the bots had to move with an AI. Like, you had to plug in an AI, and the goal of the class was to hack the other people's AI and upload your own, like find the security vulnerabilities that would allow you to upload a hacked AI into the bot. So I try and do all kinds of interesting things. So with that as a backdrop, anybody have any questions they're dying to ask about computer security, cryptography? I'm hoping to talk a little bit about cryptography tonight. We can talk about SolarWinds, Microsoft, ransomware. We can talk about psychology of security, which is fascinating. So,
hey, Seth, I've got
what
one.
are y'all in the mood for?
Let me seed one, and everybody else just drop it in the chat. Seth is in the house, can see the chats. and we're all live here. But no, my kind of burning question is for those of us that are not really intensely security literate, right, as it were, not, you know what I mean, not on that same kind of cutting edge like you are. What is the coolest security topic that nobody knows really about yet, but which the security community is kind of talking about? This thing with the medical devices is interesting because until the Internet of Things, it sort of doesn't really show up. Suddenly, right, with connectivity comes vulnerability. We talked about this on Tuesday, actually, a little bit. I don't know. What do you think? And then the other
I
comments
see,
starting to
by the
roll.
way,
So
3 questions. So I see all of you. I will get to your questions. Let me answer Chuck's question first. There's a lot of things we all try to predict, and we're almost always wrong. Let me give you an example of that, because this is important. This is okay. If you want to read a fascinating paper from 1995, look up a paper called Scanners of the Year 2000 by a guy, his last name's hard to spell, but it's Gryaznov. Gryaznov. I think it's Gryaznov. If it's not, it's pretty similar. Google will find it. You should be able to find at least a text version of this paper. And this, Gryaznov wrote one of these first papers about using heuristics, which I'll explain in a second, heuristics in virus scanning. Now, to be honest, you don't hear a lot about viruses really anymore. I mean, they're there. They're still a problem. It's almost like we just have so many bigger problems, and viruses are just sometimes part of a bigger problem that, we don't talk about them as much as we used to. Viruses used to almost be synonymous with computer security. Not really, but it was kind of the thing that everybody talked about, right? Like every consumer that had a computer was being told they needed a virus scanner. But let's actually just broaden it a little bit. Is everybody comfortable if I use the word malware to just any kind of bad software? Actually, anybody want to throw out examples of other types of bad software? I've mentioned viruses, and I've mentioned ransomware. Anybody else familiar with other types of bad software? Spyware, yeah, that's a good one. Worms, Trojans, yep. See if we get any more.
You said something about like ransomware too, right?
Mm-hmm.
Yeah.
Yeah. So there's the link to the paper. Ooh, rootkits. That's a good one. Basically, anytime somebody's written software or a program, browser hijackers, to try and subvert your computer to do something other than what you would intend it to do, it's bad. So it's malware, right? Okay. How do we stop malware? One approach is to have a scanner, and the most common type ever produced, still produced to this day, is to look for known patterns. Okay, known patterns. Do we detect a pattern that we know is associated? In fact, I actually want to show you this. I can share screen, right?
Yeah, you should be able to. Sorry,
give me just a quick second.
Since that video feed's coming through Zoom, Seth, you ought to be able to do the share, and I can alert you as to whether we're golden on that.
I just want to. Okay, cool. Let me pull this up here. And okay, this is what I want to show. Okay, let me share this. Oh, can you make me? It says it's disabled. Can you make me co-host?
What? Okay, yeah, I'll work my magic something or
I mean,
other.
I can drop the link into chat. It's just I'd kind of like to have it up on the screen.
I think this would be more fun.
I've posted the link so you can look at it, but I still want to put it up on the screen. What this is there was a publication, it's still around, but it's called Virus Bulletin. It's been around since like, I think 89, right? That predates me, in case any of you are wondering. Predates my, professional career. I would have been in middle school, I guess, grade school.
Okay, Seth, you should be host now. Change host. Yeah.
Oh, excellent. Now I can share
should be all
screen.
powerful.
Okay,
now.
I got it. Okay, can everybody see what I'm sharing here now?
Yep.
Okay, let me zoom in on this just a little bit. Are you zoomy? There we go. All right, everybody see this part I've highlighted? Okay, what is this? I see a few people typing, so I'm going to wait and see what they say it is. Yes, it's hex. It's hex. So this is the hex representation of the bits that characterize these viruses. Okay, see these viruses? This virus was named 8tunes. This virus probably originates in Germany and infects .com and .exe files. The length of the virus code is 1,971 bytes. When triggered, it will play out one of 8 different tunes. This was the code you could look for. And if you found this code, you had the virus. Okay, first of all, how many of you wished we still lived in a time when all viruses did was play a few notes on our computer? For the longest time, viruses weren't even evil. They were mostly like, watch how awesome I am that I caused a virus to spread across the world, right? But also, not only were they fairly mild and benign, they were fairly predictable. This, by the way, is Virus Bulletin from 1991. So in 1991, they could publish in a magazine the bytes you would be looking for on your computer for all of these few viruses. I mean, it's not really that many. Okay, so you could just do almost hex dump. And if you could find these bytes, then you knew you had the virus. Yeah, so, okay, yeah, we'll come back to that worm in a minute. All right, and Chuck, you said first name was fine, right?
Yep, first names are
okay.
fine.
Yeah, so Alex, we will come back to that worm, which is we need to talk about. Just let me fit. That's a great question. We'll come right back to it. And I'm keeping track of all the questions that have been asked. I know I've got a bunch, so we'll go through them. What I want to point out to you is that we couldn't keep publishing these bytes for very long. Of course, very quickly, viruses came up with ways of disguising themselves. They would do things that would change the way they would look, and so you couldn't do static scanning anymore. And the scanners had to get smarter. I actually got to look at source code from a 1995 era scanner. Their signatures for a virus was a mini program. It would basically be, a signature was jump in 5 bytes. If it's this, jump ahead 20 bytes. If it's that, jump back 3. Now look for this. Now decrypt this piece. Now do this. Now you know what virus it is. Like that's what a virus signature was even by the mid-90s, just a few years later from this, right? But there's a problem fundamentally with signatures no matter how advanced they get. You're limited in what you can detect. What's the fundamental limit with a signature? You can only detect viruses or malware that what? If it's a signature, what has to be true about the virus or malware? In order to create a signature, for example, what would you have to have? Typey. Ooh, 3 people typing. It's a race. See who gets to the finish line first. Aha, John. You have to have the source, or I'd say you have to have the sample, right? So in other words, exactly, Alex, you have to have seen it before, which means your virus scanner can't protect you from anything that hasn't been written yet, right? Now, Gryaznov was like, hey, I see new viruses all the time, and I know immediately that they're viruses. I just look at them, and I'm like, I can tell that's a virus. Well, if I can do that, he says, I can write a computer program that will do that. We're going to call these heuristics. And for those of you who've taken like an algorithms class or something like that, you use a heuristic as a guess. It's any type of, you don't have exact information. A heuristic is a guess for some kind of measurement or computation or calculation. So Gryaznov says, hey, all basic viruses, they'll work more or less the same. So we can identify these kind of conceptual steps. And if we see the conceptual steps, then we can guess it's a virus and we'll block it. So Gryaznov was really excited about heuristic. And he said, by the way, how many of you are familiar with the halting problem? Any of you had a theory class yet where you've talked about the halting problem? All right. Who wants to give a basic explanation of the halting problem? Austin or Alex, either of you feel inclined? Sure, go ahead. Yeah, so just to repeat, that was a great explanation, by the way. So for those of you who haven't had a theory class yet or have never heard of the halting problem, let me repeat that back one more time just so you can understand the concept. It's decision theory, right? We write programs all the time that decide things. And you can even call them classifiers, right? You get an input and you say, is the input X or is it Y? And it has to make a decision, right? So imagine if you had a decider and the inputs to the decider are 2 things. A program, the code for a program, and another input that's meant to be the input to that program. So it's like an input to the input, right? So you take these 2 things and you plug them into the decider. And you say to the decider, hey, decider, with this program, if I feed it this input, will it stop? Or will it get stuck in an infinite loop? It turns out you can't write a program that can solve that for all possible programs. It might be able to figure it out for some. It might have some really good calculations that allow it some good guesses, some whatever else, but it can't do it for every possible program that can be imagined, right? And this is a really important result because it shows some limits in what we can do with computing. Well, they expanded this out to show that the halting problem is true. The halting problem is a problem for all possible non-trivial characteristics. In other words, writing a computer program that can decide whether or not another program has some characteristic is impossible in the general case. It can do it for some things, it might even be for a lot of things, but it is impossible in the general case. In the 80s, a man by the name of Fred Cohen was first introducing the concept of viruses and published as part of his PhD work that you would never be able to identify all possible viruses because of the halting problem. If a program can't decide if another program has a characteristic in the general case, then you can't ever have a program that can decide whether an input is a virus, right? So you've got your antivirus program. You hand it a piece of code. You say to the antivirus program, is this a virus or not? In the general case, that can't be solved. All right, I see a couple of questions, so let people finish typing. No? Change their mind? Okay, so Gryaznov was saying we can get around the halting problem by having really good guesses. We don't need to solve it for 100%, right? We don't need to solve it for all possible viruses. What if we could identify 95% of all possible viruses with heuristics? And then we'll deal with the other 5% manually or something. But wouldn't it be great if with heuristics we could just identify 95% of all malware and be done? Did that happen? How good are heuristics today? Anybody know? Very good guess, Chad. Very, very, very good guess. Not so good. Yes. I'm just waiting to see Alex's comment. Want to not pass it before I move on. Okay. Alex says Chrome Sandbox seems pretty good. We should come back to sandboxes in a minute. Well, sure, right? So the problem is that a sandbox isn't a decider. Sandbox isn't a decider. It works with some different principles. So we'll come back to that. But in general, heuristics are still terrible. Here's an example. So getting all the way back to Chuck's original question, what do we see on the horizon? A lot of times we don't know what's on the horizon. For example, ransomware. When ransomware came out, it caught everybody off guard. It's not like we'd been pre-programming all of our security devices to deal with ransomware. In fact, to show you how old ransomware is, let's go back to the screen here. I want to show you this. It's interesting. I don't think it's mentioning here that this was actually a ransomware. Oh, maybe it was the Trojan. Maybe that's what they're talking about. So maybe that was the Trojan. So there was a thing in the I think it was even late 80s, early 90s, where it was a type of virus where it would encrypt your data and then say you needed to send money. Like it was the earliest example of ransomware. It's not that we'd never seen ransomware before, but we didn't know to expect it. We didn't know that all of a sudden it was going to take off and just blow up everything. Yeah, John, that is actually another problem with heuristics is that they often they have too many false positives is what we'd call it when it says it's bad, but it's not. But let's talk about ransomware for a minute. Ransomware really took off in about the 2011, 2012 timeframe. What changed in that time frame? Anybody know what really made ransomware suddenly just take off? There was an interesting change in society that suddenly meant ransomware was going to be a bigger problem. Good guess on mobile phones. That wasn't it. See if we have any others. Oh, everyone have it? Bitcoin! Ooh, for the win. So yes, Bitcoin. So Bitcoin was a really great way for transferring money. It's really not technically anonymous, but it's easier to do than a credit card transaction. And so now there was a really easy way for ransomware operators to get paid. Okay, so Bitcoin was one of the reasons that ransomware took off. Now, interestingly, we have all kinds of defenses for ransomware now. A lot of the security systems will monitor your computers for encryption and try and figure out if that encryption is something other than what you intended. Why didn't we do that before 2011? Why? Because we couldn't see it coming. Heuristics were not going to see it coming. We just missed it. And that's where Gryaznov was really, really wrong. Gryaznov's like, we can find 95% of everything. Except the problem is, exactly, in 10 years, there's going to be other things we never thought of. Gryaznov didn't seem to grasp or didn't catch at the time. And by the way, Gryaznov is still, I believe, at Symantec and is probably smarter than I am. So I am not claiming he's dumb. That's actually kind of my point. The smart people are going to miss things. Now, Gryaznov thought that if we have heuristics, they'll catch 95% of everything. Do you see, anybody see why that's not going to be true? Why is it not going to continue to catch 95% of everything? Yes, yes, exactly, Gabe. That's exactly the point. Gabe says people are going to change. The virus writers, it's not like viruses are random. It's not like they're human viruses that just kind of evolve. These are written by human beings. So if you're a virus writer and you know heuristics are catching these 95% types of viruses and not these 5% type of viruses, which type of viruses are you going to write? The 5%, which suddenly stop being 5%, and now they become 95%. So heuristics really, while we're, again, Gryaznov, really intelligent person, so I am again emphasizing just how easy it is to be wrong even when you're smart. So as a reminder, anybody in the class who's smart, you know who you are. Make sure you keep some humility, because someday you might be Gryaznov in this story, okay? Gryaznov said one other really amazing thing in this paper that I hope you all go take a look at. He said viruses were going to go away, not even because of the heuristics. Anybody glance through the paper yet to see why? I'm going to just say it, but he said it was going to end because of Windows. He said the move from DOS to Windows was going to end viruses. He thought he was going to be out of a job. He thought that his job was going to go away in the next few years because Windows would mean the end of viruses. You should read his argument. It's very cogent. It sounds like it would make sense. There were things he could not foresee. Okay? So, this was a really long-winded way, but I like it because it was a good way to also introduce a bunch of security concepts of saying that it's actually really hard to see what's on the future. I can tell you one thing that is kind of hot right now, and it's a hot topic item, and there's a lot of concern about it, but I'm going to be right up front and be like, I can't guarantee that this will. There may be something totally different that ends up being the big thing next year. But one topic that's a really big deal right now is the security of artificial intelligence. We are using artificial intelligence like we have never used it before. We are using artificial intelligence to have cars drive around on streets. Okay, it turns out there are some really interesting ways to try and mess up an AI. Most AIs build their operations based on data and then classification of data. There's all kinds of questions. What happens if you can feed an AI false data during the training phase? If you have access to the training data, can you come up with a very easy way of breaking that in practice? So just as an example, they found there's some very easy ways to confuse an AI with a stop sign. You know, I can't remember what it was. You put a line underneath it or through it or something, and it just completely threw everything off. How do you know if your AI is operating properly? There's a whole new area of research now called transparent AI, where we would like to make sure we understand how an AI is making decisions so that we can also tell, if nothing else, if it's been messed with. So how much will that impact you as a consumer? I don't know. Maybe it depends on the next time you're riding in an Uber that doesn't have a driver. Maybe it'll be, who knows, all the different ways it could affect you. But that is kind of a big concern right now. It's also a concern for the military, where we have drones with guns and bombs. It's potentially a real problem. Okay, I'm going to try and wrap up this very first question so I can go back up on the Discord feed and get back to some of the earlier questions and comments. But any last bits in the chat about this topic of being able to perceive the future, being able to predict, issues with machine learning? Anything you want to stop me on before I jump to the next question? Actually, maybe I should ask Chuck. Chuck, you asked the question. How did you feel? Good answer?
Yeah, great. I mean, it's a really tough question. You know, I mean, it's you know, because you can only see just a little ways around the corner anyway, right?
Exactly. Yep, exactly. By the way, if you kind of want to follow along with the industry and just kind of keep abreast of what, it won't necessarily give you the future, but you can kind of follow the trends. I highly recommend things like all the major security companies, Symantec, FireEye, all of those will put out a yearly report where they will tell you how much ransomware their systems detected, blocked, or how much they mitigated, or whatever else. And it's really fascinating. You can see ransomware go up and down, and they'll give you reasons why and how it's changing. Oh, yeah, sorry, good point. So those are really fascinating to follow. So you can look it up, like they'll give you like a 27 year-end review, and most of them will have it out for free. And of course, they're always pitching it for why you should use their systems, but it's pretty just good data to see and follow. So that gives you a chance to see where things are going, at least with some historical data. Gives you the historical data with which you may attempt to predict some future data. Okay, let's see some of these other questions, of which there were a number. Okay, there was a question about what kind of math do you use in advanced cryptography? I will confess, I'm not the mathematician I wish I was. I took a class on the abstract algebra. Have any of you heard this? This is like rings, fields, the wraparound stuff where it's all like you do addition modulo and you see if it wraps around, and if it wraps around in a certain way, you have a certain type of field or ring. I barely made it through that class, and I realized I'm a computer scientist and not a mathematician, and I'm going to not focus on the math side of it. So I'm what you would call an applied cryptographer, which means I start with the basic axioms, not axioms, I'm sorry, the primitives are what we call them. And I know the properties, I know when they can be used and when they break. I understand the math well enough to kind of get the basics of why it works. And then as an applied cryptographer, I can apply those axioms into building a secure system. But I am not going to be out designing any new cryptographic operations with the crazy math, because it's not that's not where I was given my talents in life. It's really fascinating stuff though. Like, just to give you an idea, we're going to talk about cryptography a little bit. So without even explaining the math, any of you ever look at how RSA works? For those of you who know what it is, RSA is this thing where you have a public and a private key. And it has this really weird math property that what you encrypt with one, you can decrypt with the other. That's weird. And you can derive the public key from the private key, but not vice versa. I mean, the math behind it is just kind of mind-blowing. I mean, it blows my mind. Maybe some of you are mathematicians and you're like, what's so hard about it? I thought it was easy. Okay, so that was a relatively short question, but did that answer your question, Andrew? I believe it was Andrew that asked that question. I'll assume you'll follow up if you want to ask more about that. Okay, let's see. What was the other question here? Best degree or what to do to go into security. I'm going to take that one at the very end. I may have that be an after class discussion. It's a good one. I get asked it all the time. The answer is it depends, and there's a lot of different things we could talk about. I'm going to postpone that one. Also, if you feel like you're really interested in a career in security and you don't know how to get started, you can also contact me after class, email, or whatever else. I usually have Chuck just share my info so that you can contact me. And I'm happy to also answer that in an offline way too. Okay. Alex said, would you say viruses are less common because targeting users is less rewarding than hacking a web server? Well, Alex, what I would say is it kind of comes back to the idea that viruses used to be somewhat benign. And so we mostly talked about them as a virus because of how they transmitted. Now that we actually have serious damage like ransomware, you could have a ransomware virus. But most people are now talking about the impact rather than the mechanism of transmission, or at least a lot of times they are. So nobody talks about how, we generally don't classify the ransomware by how it's transmitted. We just say it steals your money or it encrypts your files and demands money. So it still might be worthwhile to target an individual, which ransomware can do and does. But then the reason we talk about the ransomware more is now we're way more interested in the damage being done than how it got on the computer as a society, anyway. Okay. There were still other questions. Oh, we had the question about the worm. I'm just trying to see if I missed anything else that were super important. Let me talk about the worm for a minute, because anybody know what the worm's called? It's named after the guy who wrote it. Shout it out if you know it.
Seth, was this the Kevin Mitnick thing, or is that a different thing?
Yeah. But it was
that
called
doesn't
the
tell
Morris
you.
worm.
What's that?
So it was the Morris guy.
Okay.
The guy who was the son of the NSA.
So not Mitnick.
No.
Okay, this is a different, okay.
Let me, because I know it's, no, Mitnick was the other thing. Let me just,
He was similarly young, precocious, thrill seeker.
yeah. So the author of the Morris Worm, his name was Robert Morris, and his father was, he was the son of, okay, so his name was also Robert Morris, I guess, but his father's name was Robert Morris, who at the time was working for the NSA. I guess he wasn't the head of the NSA, but he was a person of some significance, I guess. But yeah, so let me tell you a little bit about, yeah, exactly, at the end of Cuckoo's Egg. So the Morris worm was really fascinating, and it was, what was this, 89, 88, 89? But the funny thing is, yeah, it's 88. But the thing is, it actually shows us a lot of issues with security today. Like, it's still very applicable. So that's why it's worthwhile taking a minute to talk about. So how did the Morris worm work? Okay, anybody want to give a real brief explanation of the difference between a virus and a worm? Anybody know? Ever read about it before? So I'll explain. This is just, I maybe should have explained it a minute ago when I was talking about transmission. So some of you may have heard of the military concepts of a payload versus a delivery mechanism. Okay? Yeah, Alex, they do. And I'll come back to your answer here in a second. So payload is the thing you want to deliver at the other end of, whatever it is whatever package you're trying to deliver to the enemy with your weapon. And then there's a delivery mechanism. So let's say that you want to do a nuclear strike. You could deliver that with an ICBM. That's an intercontinental ballistic missile. You can shoot it from one side of the world to the other. The missile is the delivery mechanism, and the nuclear warhead is the payload. There are other ways of delivering a nuclear payload. You could have a person have it in a truck and just drive into the middle of a city and detonate it, right? So difference. There's the thing you're trying to deliver, and then there's the way you're trying to deliver it. Malware has often been categorized by how you try to deliver things. A virus, for example, was delivered by inserting data into other executables. So if you know anything about assembly, the processor will start with the first instruction, and then it goes down the line, and if it gets to a branch, it branches, but it can jump all over, and that's how it works. Well, a virus would take an existing program, append something maybe at the end, and then there would be an instruction that would be overwritten that would jump from what was supposed to be there to the end, do the virus stuff, then jump back after doing the replace step so that you didn't leave a step out, right? But they called it a virus because, kind of like a human virus, it could attach to another program. And in fact, it wouldn't even execute unless it were attached to another program. Like a virus can't live unless it's attached to one of your cells. That's what a virus is. A worm isn't necessarily attached to anything. A worm is a program that, like Alex says, it tries to self-replicate. So if it can figure out how to spread itself, and the reason they called it a worm, though, is it would usually try to worm its way into a system by finding vulnerabilities that were possibly unknown. Now, nowadays, we call vulnerabilities we don't know about 0 days. That means it's being used before anybody has a defense for it, and that's called day 0. And so these 0-day vulnerabilities are ways of getting into systems that you can't have defenses for because you don't know anything's broken. So the Morris worm used what we would now call some 0 days, some vulnerabilities in internet programs, as well as some basic password cracking to crack weak passwords. The most common password is still password. So, and he would use this to have, and it would be written in C code. Most Unix and other machines had the C compiler, so it would copy itself over, recompile it on the new machine, and then it would run and execute. And now you have another copy on another machine. And then what happened is, the reason it actually caused such a problem is that he had written something incorrectly in his worm. The worm was supposed to check for itself and not launch again if it was already running on the same machine. But it turned out he had an error in his code, and so it was copying itself to other machines over the same machine over and over and over and over again until those worm processes were taking up all the processor and it was bringing the system down. People discovered it, they wrote defenses for it, but it was so weird. Like, the internet is actually really fragile, and it was something where they would have to like call up, and because they had to be like, okay, I'm going to bring my system up, let's get our systems up, then you can bring your systems up, and they had to kind of like re-bootstrap everything. Real mess. So I like to talk about this story for a couple of different reasons. The first one is, just like today, some things just haven't changed. Today, people still get in by cracking weak passwords. Have any of you heard of the Mirai Botnet? It's a few years old now, and so most of you probably haven't. But, I mean, this was like 2015, 2016, not that long ago unless you're a college student. So the Mirai Botnet had a worm. So have any of you ever heard of a distributed denial of service attack? That's where you have like a gabillion machines all send traffic to one machine to overload it. The Mirai Botnet took over a bunch of machines to send massive amounts of traffic to take down websites. Mirai took over IoT machines, Internet of Things machines, that had been left on with their default passwords. So it'd just go take over machines that had crappy passwords until it had all of these machines all over the internet. It was almost Skynet, right? Like, I have taken over all of these machines and they all do my bidding. And my bidding is send network traffic to that site to make it crash. So how much have things changed? We still have things that get broken all the time because of bad passwords. Problem number one. The other parallel is, like I was already saying, with these 0 days. How do you defend against something that you don't know is broken? Technically, in the Morris worm case, some of these were known vulnerabilities, but they were kind of like off everybody's radar. Nobody thought that they hadn't been patched yet. And same thing today. So many servers. The Equifax hack, which was also a few years ago, but one of the huge hacks where massive amounts of personal data was lost, was because they hadn't patched a server they knew they needed to patch. Okay, so still a parallel to today. And then the other thing that's so important is he ran into his own bug. Like, his own bug is part of what brought him down with this Morris worm, right? The worm itself had a flaw. This is actually really common. No matter how good the virus writer or malware writer or worm writer or whatever tries to be, they often make a mistake, and the mistake is how we track them, find them, and figure it out. The guy who wrote Mirai got caught. And he got caught because there's a security researcher by the name of Brian Krebs. He has a blog that's great to read called Krebs on Security. He is a master Sherlock Holmes style investigator, and he searched public internet code until he figured out who the writer was, like tracing things that were in the Mirai code to things that the person's public persona had posted on the internet, able to find the forensic pieces to put it all together. Yep, that's the one, Krebs on Security. Okay, so if any of you have heard about Stuxnet, which was the United States and Israel launching a cyber attack on Iran, there were also issues where our meaning American attack had mistakes, and that was part of how it was. How, I can't remember which thing it was. There was something about it that it tried to delete itself and it screwed up or whatever else and allowed people to track it. So you can really take a look back in history and see that even though the technology has changed drastically, a lot of the basic principles still are the same from then to today. So even though I'm going to talk more specifically later about how to get into a career, one of the things that's actually really important is actually to just be a good computer science student and a student of history. And the more you are able to learn the principles that are kind of underlying all of these issues, then even as the vulnerabilities change, even as the attacks change, you still can kind of trace it down to first principles, right? And see the parts that have remained invariant. Okay, so it's really useful to analyze the old attacks in order to understand the new ones and what's coming. This actually might be a really good segue into this other topic of SolarWinds. So I'm going to jump to that in a, if there are, anybody have any other questions about Morris worm or how that applies? Okay, I have one vote to move on. All right, so let's talk about SolarWinds and what's going on there. Anybody want to give like an overview of what they know about it? I know a couple of you commented on it, so I'm curious to see if what you've read in the news or whatever. What do you know about what happened? Ooh, multiple people. It's a race. Camille takes the lead. Okay, but Camille says very little. But it's okay, Camille. You were the first one to type that out. Yes, SolarWinds is a cybersecurity company that Microsoft used. Yep. Actually, SolarWinds is a company that lots of people use. Like FireEye, who's a security company, and others. I'm waiting to see just these last couple of comments. Hey, Chuck, what time does your class end?
I meant to say that earlier. 5:15 is official stop time.
Okay, gotcha. Yeah, exactly. So like Ammon says, SolarWinds was hacked to get access to other people's stuff. So what do we mean by that? Have any of you heard, as you've been reading the news articles about it or the headlines, that it's what we can call a supply chain attack? Has anybody seen that mentioned? If you haven't, some people are referring to it as a supply chain attack. Now, to talk about a supply chain attack, I want to back up in history, and let's talk about another paper that I'm sure Chuck will post here very briefly. And this is called Reflections on Trusting Trust by Ken Thompson. Reflections on Trusting Trust by Ken Thompson, 1985. Now, this paper got a big award. It's a really brilliant paper, just mind-blowing. Ken Thompson says, hey, we have these compilers, right? Like, okay, let's leave the compiler out for a minute. Let's say we've got this program that's a login program, right? It's the program that does login for Unix. When you type in your username and password, looks you up, finds out if you're authorized, and if so, grants you permission. I can write a backdoor, he says, into the login program, right? I can have a backdoor that says, if username equals my secret cheaty username and password is my secret backdoor password that you enter with super user access, even if you're not in the password file. All right, but somebody might see that in the code. Somebody might see that in the code. So what to do? Ah, Ken Thompson says, I have a compiler. What if I corrupt the compiler? I'm going to corrupt the compiler that when it is compiling the login program, that it will insert this code so that what gets compiled is my login program with the backdoor. Now that already is pretty devious, but then Ken Thompson went one step further. Ken Thompson said, wait a minute. Somebody might look at my compiler source code. Somebody might look at my compiler source code and see the backdoor insertion. Well, he said, my compiler is itself compiled. My compiler is also compiled. Okay, he says, I've got an idea. What if I take a compiler and I corrupt it so that when it compiles the compiler, it modifies the compiler so that when that compiler modifies the login program, it will insert the backdoor. Now, what's really great about this is compliception. 10 points for referencing inception. His point is you can then delete the source code for the compiler. The bad source code with the evil, you can delete it. Because now when they get new source code, right, they get a new update, the compiler will recompile the new compiler and insert the evil source code. So there is no source code on the machine that has the evil in it. It's only in the binary of the compiler, which will either compile the login program or compile the compiler. His point was you can do a source code review of this computer from top to bottom, and you will not find the injection code. He wasn't using the term, but basically, Ken Thompson was describing a supply chain attack. I don't need to attack your code directly if I can attack your supply chain. Now, I use examples like this all the time with people when I tell them why I'm not comfortable with electronic voting. Just to be clear, I've made peace with electronic voting where you use the electronic voting machine to generate a human-readable ballot that you still go drop in a ballot box. I'm comfortable with that. I am not comfortable with a system where you vote and it is captured, recorded, stored, tabulated 100% electronically. I am not comfortable with that. Why? Well, I'll tell you a story. I have a friend who works in elections, and she's a powerhouse. I mean, this girl, she is one of the best leaders I've ever met. Amazing leadership. Just she blows me away every time I'm in her presence. And she was interested in trying to do some electronic voting, and she was talking about investing in a company. So she contacted this company and had them contact me because she knew I was in computer security. Companies like, we would be interested in hiring you as a security expert to help us vet the security of our voting system. And I said, well, I'm happy to take your money. I mean, if you want to pay me, but just so you know, I'm never going to be a fan of your system. Like, I'm never going to tell other people I think they should use it. You might not find that good marketing, you know, if somebody ever asks me, right? And he said, why not? We have all these things we're going to do for security this, security that. And I said, answer me this question. Would you be comfortable with your software development process, developing the software for controlling the nuclear launch codes for this country. I want you to think about that, I said to him for a minute. I said, I want you to think really good and hard. You know how your software has been being developed. If I told you that your software was now going to go in and control our nuclear systems, our nuclear missile systems, would you be comfortable with that? How would you feel about that? Very long pause on the other side. I said, now imagine for a minute that you do trust your systems, right? You actually think you have software development that is so good, you would trust that software controlling nuclear weapons. How sure are you that all of your supply chains are protected? Are you sure about your compilers? Are you sure about your libraries? Are you sure about the Coke delivery guy who's refreshing your vending machines? How much access does he have to your systems? Because you are messing with the systems that decide who is the president of the United States who has access to our nuclear weapons. I am never going to be comfortable with whatever you tell me about how secure it is. They have not called me back. I do not work for them. They have not asked for any more from me. I told them I'd do my best. I mean, I could give them an opinion. I could help them find this. I could help them find that. But this was always going to be my position. Not super excited. Okay. So, supply chain. Supply chain is really, really, really hard to solve. I'm going to talk about supply chain in two ways, and then I think we're going to be at the end of time. And then what I'll do is, I did this guest lecture last time, and I stuck around for people who wanted to ask questions, especially questions about getting into the industry. But let's take two other topics here. Aha, XKCD. I think I've seen that one before. Okay. Okay. Let's talk about supply chain in two things. Let's talk about software supply chain first. This is where SolarWinds fits in. SolarWinds, if I understand it correctly, and I haven't done my own deep investigation, so this is what I've been getting from press reports. SolarWinds, as I understand it, is basically a company that monitors your systems to see if they're out of date and need patches or needs updates, and then delivers the updates. This is normally a very important process because your systems are often vulnerable when they're not being updated. But SolarWinds is it's self-compromised. And then what happens is, instead of delivering updates that secure your systems, they're delivering updates that install the backdoors onto the systems. So SolarWinds takes the place of the evil compiler in the Ken Thompson paper. All right. So it's kind of an interesting attack, because they really did hit a system that people were relying on, including a security company like FireEye. And so by compromising this trusted back channel, they introduced these vulnerabilities. Okay, so that's a software backdoor, a software supply chain problem. Now, the other supply chain problem is in hardware. Anybody know where our circuit boards are manufactured? Yep, China. So, and by the way, if there are any Chinese students in the class, I am not picking a winner here. I'm not talking about which country is a good country or a bad country. I'm just saying countries spy on each other. And From a security perspective, we talk about countries spying on each other. So nobody be offended by what I'm about to say. China is spying on the United States. The United States is probably also spying on China. One of the ways that we know China is spying on the United States is that they insert a lot of backdoors into software and hardware. So one of the ways that this happens is that we have circuit boards that are designed in the United States. They lay out all the architecture, whatever else, and then they ship it to a place in China where it's manufactured. There are places where those circuit boards are being manufactured with a backdoor. And by the way, just to, again, not picking on China, the NSA inserted backdoors into Juniper's VPN systems and was clear text reading everybody's VPN traffic. So again, not picking on anybody. But China manufactures these circuit boards and sends them back with backdoors in it. I have a colleague who's actually working on research right now for how you detect and disable them. They're very, very hard to find. And they usually have some very weird trigger that allows you to turn them on. You do some sequence of combinations that, I mean, it almost represents a cryptographic key. So it's not like you'd ever come across it and test. And then it flips the board into some other kind of state with these hidden state machines. I'm just trying to point out how far down the rabbit hole this goes, right? The software that you are trusting to secure you right now is built on a layer of trust, which is built on a layer of trust, which is built on a layer of trust, which goes down so deep, it's very difficult to secure it from top to bottom. Okay, I think that's kind of where I'm going to tie up my bows. Chuck, do you want me to throw it back to you or questions back to the class?
Well, we're actually just a couple of minutes from wrap up. And I think that we can sort of do kind of a thank you. And then the last one we really had to do with careers and stuff. And so one thing we could do, I'd probably recommend, you know, and nobody needs to feel like they need to stay, you know, longer for that conversation. Not everyone's interested in a career in security. And like you said, Seth, there's a lot of variables right at play. And if there are like 4 people that stay behind, they can ask their 4 little sets of variables and get a really tuned answer. But in a generic sense, it's like, golly, how do I pursue a career in software? You know, it's like the same, you know?
Yeah.
Yeah, so I think that's probably what I would do. And what I'd like to ask everyone to do, and Seth, you're the first guest speaker of the semester. If everybody could please just unmute your mics for a second and just give Seth a golf clap. There's an effect that happens that makes me weirdly happy. I don't know why exactly, but I would just like to do it. Can everybody please just do that? Unmute all your mics and then just give it. Are you ready? Okay, let's do it.
Nothing. I have a couple clapping.
Thank you. Thank you.
All right. So, Seth, that's kind of the official wrap.
Nice.
Let me see. Is Devin in here? Devin, do you want to run the where's not other Devin, but Devin. I think that the Autobot is going to roll here in like 2 minutes. If you just stick around for the auto, we call it the cancel bot. Seth, you might be amused, which sort of automatically does attendance and stuff. So if you mind just hanging out till you see the Autobot run, the cancel bot. But in the meantime, I would say those that want to talk about career stuff, that you ought to dive in right now, and everybody else, you know, can kind of yeah, I know, other Devin, I got it. But yeah, I think if you have
other questions,
or if there are a few other questions, yeah.
I actually had intended to get to cryptography today. I never did. Anything you want to ask, you know, I'll stick around for as long as you're interested.
I, for one, am shocked and offended that you didn't cover the entire field of security in an hour and 15 minutes at a thorough and deep level. I just want to say to everybody in the class, security is one of those things that when I was an undergrad was not a thing. It was not a thing. And those things you were talking about, the Morris virus, you know, that was like I finished my undergrad in '88. It was all kind of beginning to be a thing, but networking wasn't really a thing either. So if I could go back and turn the clock back and become an expert at anything, it would probably be security. And it's never too late, which is why I have Seth's book and a couple others actually right here in my must learn next.
Actually, before everybody leaves, let me recommend one free reading book. In fact, I'll drop it into the chat. Now, when I say free, he has a new 3rd edition, and his deal with the publishers is that they sell it for a few years, and then he gets to post it freely online. But the 2nd edition is still freely available and is still amazingly relevant and good. So if for those of you just looking to dig into computer security a little more, this free book is just one of my favorites. I still use it all the time. I cite from it in the litigation support that I do. I refer people to it in my consulting cases. I tell everybody about this book. So there you go.
Awesome. Okay, and then also everybody knows that I've been nursing this stupid back surgery repair. So when class is over, I'm out. Okay, so since it's too late for me to pursue a career in security, in a sense, I'm going to drop out. And but Seth, sincerely thank you for always cool, always interesting, and I think the topic is obviously very relevant to our sort of. Oh, I didn't actually say this. When I first took over this same class at BYU, Seth was my TA for that CS 404 class not found. Yeah, that was a long time ago.
It was. Anyway. We were both younger.
We were both younger, yeah, and one of us still had white hair. So.
And the 2 of us could play racquetball back then.
And we used to play racquetball back then. No, I'm coming back. I'm coming. Post back surgery, racquetball might be in my future again.
There you go.
All right. Hey, thanks everybody. I
didn't see the cancel button go. Stay on Discord.
Yeah, just hang out on Discord. And then if you want to do any kind of screen share in Discord, all the streams will shut down. And then you can just be native in Discord. We'll kill the Zoom, and you can kind of just pop up there.
All right. I'm going to end Zoom then.
Yep. I'll let you kill it. Okay. All right, and I'm going to drop out as well and kill my stream. So see everybody. I will see you all next week.